projection is nothing but the shadow of the vector A on the line L, and vector P is the unit vector. When angle between the two vector is unknown, we can use this formula, that is A dot B divided by magnitude of B. Now what is the formula to find out projection of vector A on vector B? It is given by vector A dot B cap. If I show vector A plus vector B dot vector A minus vector B is equal to 0, then they are perpendicular. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to study about the projection of a vector, which is one of the application of the dot product. Now what is this projection of a vector? So if P is the unit vector along the line L, and then the projection of vector A is given by vector A dot P cap is equal to magnitude of vector A cos theta. So how you are going to get it, and what do you mean by projection? A projection is nothing but the shadow of the vector A on the line L, and vector P is the unit vector. So thus here this distance and the shaded line here, which is the black color, represents the shadow of the vector A on the vector L, that is the line L here. So in this similar way, how we are going to get this as modulus A cos theta? Now here, if theta is the angle between the line and the vector A, then if you apply cos of the angle, that is cos theta, then that is equal to adjacent side by hypotenuse, that is vector A. So here vector A means we need to take the length, that is why we need to take the magnitude of vector A. So therefore here we will get magnitude of A cos theta as the unit vector P here, and thus P cap can be magnitude of A cos theta, or we can say vector A dot P cap is equal to magnitude of A cos theta, where A represents the length of the vector and theta is the angle between them. So similarly, we can also find the projection of vector A on vector B, that is the projection of one vector on the other vector. So clearly here is we have vector B and vector A, and clearly this region represents the projection of vector A on vector B, and it is given by A dot B divided by magnitude of vector B whenever theta is unknown. So here, suppose if you know the angle theta, here also it is nothing but magnitude of A cos theta whenever theta is known. When angle between the two vector is unknown, we can use this formula, that is A dot B divided by magnitude of B. A dot B is nothing but magnitude of A, magnitude of B cos theta, and denominator we have magnitude of B. Thus when you cancel, this is magnitude of A cos theta. So A dot B by magnitude of B is nothing but magnitude of A cos theta. Thus the projection of vector A on vector B is given by vector A dot B cap, where B cap is the unit vector along the direction of vector B. Now let's find out what are the important observations we study here. We know that vector A dot B cap is equal to magnitude of A cos theta, or AB cos theta divided by B. So one and the same. Now suppose if angle between the two vectors are 0, that means they coincide. Suppose you take this initial point as A and this point as B. So the vector AB coincides with vector AB only, that is there is no inclination between the two vectors, and therefore the projection of vector AB is vector AB itself if theta is 0. Now suppose if theta is equal to pi, suppose if this is vector B and this is your vector A, then the angle between them is clearly 180 degree, which is pi. Then the projection of vector A is BA, that is negative of the vector AB. And if the angle between the two vectors, that is vector A and vector B, then there will be no projection. Therefore, we say the projection of vector will be 0. Thus, we can say here vector A dot B cap is equal to 0. When this is possible, whenever theta is equal to pi by 2 or 3 pi by 2. Next, find the projection of the vector A 2i plus 3j plus 2k on the vector I plus 2j plus k. Now, what is the formula to find out projection of vector A on vector B? It is given by vector A dot B cap. And B cap is nothing but vector B divided by magnitude of vector B. So, A dot B is nothing but the product of the corresponding components, that is I to I, j to j and k to k. So, that is we have 2 into 1 for the I component plus 3 into 2 plus 2 into 1. And magnitude of vector B is nothing but the length of vector B, and it is given by square root of 1 square plus 2 square plus 1 square. So, thus we have here 2 plus 6 plus 2, which is 10, divided by root 6. So, this is the projection of vector A on vector B. We can also find out projection of vector B on vector A. That is, the formula is like this. Vector B A cap. Just we need to take out A divided by magnitude of vector A. So, B on A means it is A dot by vector A. A on B means it is A dot B by vector B. So, we can also find projection of vector B on vector A. Next, find the projection of vector A I plus 3j plus 7k on the vector B 7i minus j plus 8k. First, let us take out A dot B. So, A dot B is the product of the corresponding components, and projection of vector A on B is nothing but A dot B cap, which is nothing but A dot B by magnitude of B. Now, what is A dot B? So, 1 into 7 and here plus 3 into minus 1 plus 7 into 8. So, now magnitude of B is square root of 7 square plus minus 1 whole square plus 8 square. So, 7 minus 3 becomes 4, 56. 7 8s are 56. So, 56 plus 4 becomes 60 divided by 7 square is 49 plus 1 square 50 plus 64, which is square root of 114. So, this is the projection of vector A on vector B. Next, so here we will come across again with the problems, a kind of dot product. Now, if vector A is 5i minus j minus 3k and vector B is I plus 3j minus 5k, then show that vector A plus vector B and vector A minus vector B are perpendicular. To show that two vectors are perpendicular, it is enough to show that their dot product is 0. Now, if I show vector A plus vector B dot vector A minus vector B is equal to 0, then they are perpendicular. Now, let's find out what is vector A plus vector B. So, vector A plus vector B means adding the corresponding component. So, 5 plus 1 is 6i, minus 1 plus 3 becomes plus 2j, and minus 3 minus 5 becomes minus 8k. So, this is vector A plus vector B. Next, we will take vector A minus vector B. So, A minus B means 5 minus 1, which is 4i, minus 1 minus 3 minus 4j, minus 3 plus 5k, because when you change the sign it becomes plus 5, so it is plus 2k. Now, let's take the dot product of vector A plus vector B and vector A minus vector B. So, when you take the dot product of these two vectors, multiply the corresponding component. 6 into 4, 24. 2 into minus 4, minus 8. Minus 8 into 2, minus 16, which is equal to 24 minus 24, and hence it cancels. we get this as 0. So thus we get the dot product of these two vectors are 0. So therefore what we can conclude, vector A plus vector B is perpendicular to vector A minus vector B. Hence proved. Next, if vector A is equal to 2i plus 2j plus 3k and vector B is equal to minus I plus 2j plus k and vector C is equal to 3i plus j are such that vector A plus lambda into vector B is perpendicular to C, then find the value of lambda. They have given vector A plus lambda B is perpendicular to vector C. So whenever one vector is perpendicular to other vector, that means their dot product is 0. So using that, we need to find out the value of lambda. So here we are going to write vector A plus lambda vector B dot vector C is equal to 0. Now let us take vector A plus lambda B. That means we have to take the sum of vector A plus lambda into vector B. So what I will get? First I will take 2 plus minus 1 into lambda means minus lambda into I. So this is for I component plus j component 2 plus 2 into lambda. So lambda into 2 becomes 2 lambda. So 2 lambda into j plus k component here 3 plus again lambda plus lambda. So into k. So this is our vector A plus lambda B. Now we will take the dot product with C. So what is C? 3i plus j. So this is equal to 0 now. So now we will take the dot product of these two vector I components. First we will multiply. So 2 minus lambda into 3. Next we will take for j component, that is 2 plus 2 lambda into 1. Plus there is no k component, so it is 0 and the whole vector or the dot product is 0. So next we have 3 2s are 6 minus 3 lambda plus 2 plus 2 lambda is equal to 0. Now we have minus 3 lambda plus 2 lambda. So 6 plus 2, 8 minus lambda is equal to 0, or we can write lambda is equal to 8. So this is the value. So by concluding that their dot product is 0, we can find the value of lambda as 8. Next, if two vectors, vector A and vector B, such that vector A is equal to 2, that is the magnitude of vector A is 2 and magnitude of vector B is 3 and A dot B is equal to 4, find magnitude of vector A minus vector B. So let me take magnitude of vector A minus vector B whole square. So using the form of A minus B whole square, this is equal to A square, which is magnitude of A square, plus B square, which is magnitude of B square, minus 2 into vector A dot vector B. So magnitude of A is 2, so therefore it is 2 square. B is 3, 3 square, minus 2 into A dot B is given as 4. So it is 4 plus 9 minus 8. So thus we are getting magnitude of vector A minus vector B whole square is 5. So therefore magnitude of vector A minus vector B is equal to root 5. So thus using the identity, we can find the magnitude of vector A minus vector B is equal to root 5. So these are very simple problems in the dot product. Let's recall what does dot product says. So dot product of any two vectors is given by A dot B is equal to magnitude of A, magnitude of B cos theta. So thus what we can say, so if the dot product is 0, that means the two vectors are perpendicular to each other. That means angle between them, theta is equal to 90 degree. The two vectors are perpendicular. So if cos theta we need to find out, then we can say that A dot B divided by magnitude of A, magnitude of B. So this is how we are going to find the angle between any two vectors. Just find their dot product and find their length. Using this ratio, we can find the angle between them. So we will get cos theta is equal to some value. Then theta can be written in the form of cos inverse of angle. So using inverse trigonometric formula, we can find out the angle between the two lines. And one more thing is, that is the projection of a vector. So projection of vector on vector A on B is given by vector A dot B cap, and this can be written in two form, that is A dot B by magnitude of vector B, or we can write magnitude of vector A cos theta. So this is possible whenever theta is known, whenever angle between the two vectors is given, and if it is unknown, we can use A dot B by magnitude of vector A from the component form of the vectors. And other than this, we can show that two vectors are perpendicular by showing their dot product is 0, or we can also find out unknown values by given condition that they are perpendicular. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.